Welcome. If you have not done so, please go watch part 1 of this series in the same channel. Much of what we are doing here is dependent on that. You can also find the related articles and the Git repository through these links. In part 1, we implemented the REST API adapter. Now let's move on to the domain service. We start with get stock position service. Let's generate a test for that. For the test, we need a subject and the three sections, the arrange, act, and assert sections of the test. Now let's go ahead and act on this subject. The subject's method is get and takes two parameters, user and symbol. Let's generate the test data for both user and symbol, and for that we go back to our faker class. We'll store the result of this method in a local variable. This method is dependent on a repository. So let's create an interface for that and a mock object in this test. The interface of the repository is a domain concept, so we'll create it in the domain service. And now that we have that, let's go ahead and create the behavior, specify the behavior of this repository. We need to find a stock position based on the user and the stock symbol. And in this case, I'm using the method name that's specified by Spring's data repository. This is to simplify an integration with this repository, with Spring's repository later on. You don't have to use this same method name. In fact, this can be any method name if you intend to implement the method yourself. Now we have to inject the repository interface into the service, into the domain service. There are a few ways to do this. I'm going to inject it as a constructor parameter, and this is the recommended way to do it. One of the advantage of doing this is that you don't have to use Spring framework to do the testing during the testing. So this speeds it up considerably. And the constructor dependency injection is also the recommended way for Spring's dependency injection into classes. Now that we have that set up, let's go ahead with the verification. We'll use a step verifier, and with the result, create a step verifier with the result. We verified that the fixed stock position is the value that's returned before the publisher, the mono, ends. Now let's implement the method so that it passes the test. To do that, we'll call the repository with the parameters and return the result. And when we run the test, we see that it passed. Returning to the domain service, we go ahead and clean it up a bit, and then rerun the test, and again it passed. Now that this is implemented, let's move on to the other domain service for the get stock market value service. Again, we start by generating the test class. We arrange the test method into 3 sections: arrange, act, and asset. And we will create the subject and call the method on it. And as before, we will generate the test data using the domain model faker. This domain service is dependent on getting the stock market price from an external source. So let's create a port and interface to this adapter for getting the market price and specify the behavior for it. This interface is part of the domain service, so let's create it in domain service, and it should be an interface instead of a class. We store the result of the call in a local variable. Now let's move on to the verification. Again, we create a step verifier from the result. And the result should be an amount calculated from the quantity, the number of the stocks, and the price. So in this case, we'll assume that we can simply multiply these two variables to get the result. We'll first fix the method on the port to make it reactive, to return a mono instead of just a big decimal. And we inject the port into the get stock market value domain service through the constructor parameter. And now let's go ahead and complete the method in the domain service and see if the test passes. And we run the test and it passes. So we are done with this. Again, we clean up the code before leaving it. We are not so concerned with the red line that's under the get stock market price port, since we have not implemented the class for it. Returning to the test class, we again clean up the code before we leave it as done. Now let's move on to the repository. We have specified the stock position repository previously, and we need an implementation for it. And for that, again, we start by creating the test class. We'll call this an integration test, since we'll be integrating with a database for this test. The database that we have selected will be Mongo reactive, that's included through the reactive MongoDB dependency. And besides the Spring Boot starter, we'll also include the embedded MongoDB for the testing. This will be annotated with a data Mongo test. We'll auto-wire the repository into this test. Again, we are not so concerned with the red line under the repository, since the repository is still not implemented. And this should go away once we implement it. Again, we set up the call using the fake test data and store the result of this call in a local variable. We can now move on to the verification. We use the step variable again. And we use the asset or function, since there are a number of different assertions that we want to make here. Since this is an integration test, we want the result from the method to come from the database itself. And to make that happen, we need to seed the database with that with the expected result. We'll first do a delete all, so that we start from fresh, and then we have to insert the fake data that we've generated. Both of these methods have to be added to the repository interface. This is, in this case, maybe the easiest way to do this. If you have other ways to seed the database without having more specification on the repository interface, you go ahead and do that. But here we are using this as the most direct method. Okay. Again, I've chosen to use method names and signatures that are similar to that of the Spring Data repository to simplify the integration later on. Since this is a reactive stream, I'll want to use a block to make sure that it's completed before we move on to the next stage. Now let's go ahead and implement the repository. I've chosen to use Spring Data's reactive Mongo repository interface for this. And as I mentioned before, I've used exactly the same method signatures from this repository, and this simplifies this integration. I'm specifying a stock position document, which is going to be a subclass of stock position, which is the domain model. And this is to separate the specifics of the MongoDB, things like the ID and other types, from the domain service itself. You can choose not to do this. The overlap is not very much, but for demonstration purposes, I've chosen to take this approach. We use the ID annotation for object ID, and this is annotated with the data annotation from Lombok. And to make it work, we need to implement constructors for stock position. So let's go ahead and do that. And we also need to implement the constructors for stock position document. Let's now return to the integration test. Okay, everything seems fine, so let's go ahead and run it. And we find that it does not pass. So let's take a look at what's happening. It says that it's not able to load the application context. So remember that we have not annotated the repository interface with the repository annotation. So let's go ahead and do that and rerun the test. Okay, that seems to be going further, but again, it's not. It fails. So let's take a look at the error messages again, and we find that okay, there's no property user found for type stock position document. So we are trying to search for user when it's not specified. This should be specified in stock position. So going back to stock position, let's add in the user field, which is a string. We need to fix the code in other places for this change. So let's go ahead. We start with the test data faker. So we need to add the user field for the initialization here. And we'll also go ahead and fix the places in the test that use this test data figure. That seems to be the last one. Let's now run this test to make sure that it's okay. Also, we rerun the get stock position and market value API test that's been changed to make sure that that's okay. Now we are ready to run the repository integration test again, and it passes. Okay, so we are done with that for now. Let's add one more test to this repository integration test. We want to test that when there's no record found, that the correct information is still written, which is an empty mono. Let's run the test now. And it passes. And to complete this test, we would run the test in this entire test class again. Now let's move on. We will implement the adapter for the get stock market price port. Again, we'll start by creating the test class, and since this is an adapter, we'll again use an integration test, which means that the implementation should be calling the external data source. We use auto-wired to set up the subject in the test class. We store the result of the call in a local variable and set up a step verifier with the result. And since this is an external data source, we don't know much about it except that it must be more than or equals to 0. So we'll include that in our test. The result should be returned as a big decimal. So we use big decimals 0. For the stock market price, we use an external service, Alpha Vantage. Alpha Vantage comes with a large number of free services, and we'll be using the time series daily endpoint for this. If we click through the sample link, the demo link, you can see a sample of the JSON, the JSON output. We'll copy this sample link right now, and we'll start the implementation using this. So let's go back. We'll create a new package, Alpha Vantage, for this implementation. And we create a class, an implementation class. We'll call it Alpha Vantage Get Stock Market Price. And this will implement the Get Stock Market Price port interface. We'll implement the methods that specified in the interface. And we'll use web client from Spring's Webflux package to access this endpoint. Okay, so for URL, we'll just use the URL that we have copied previously. Okay, so that's the let's turn this into a string. And we'll want to make this URI more generalized by moving the query parameters out to their own sections. And one of this query param is the API key. So we need to specify an API key, and since we don't want to directly have this API key in the code itself, we need to create this as a configuration object that we can read in from the environment. And we'll set up the value in application properties, as well as in the IntelliJ's test configuration. We'll expect a JSON result from Alpha Vantage. Let's specify a class for this JSON. Now that we have this JSON class, let's verify that this JSON class actually matches the JSON that's returned by Alpha Vantage. We'll create the test class first. And we'll test this JSON class against a sample file. We need a sample file, so let's get one from Alpha Vantage. Previously, we have seen that there is a sample file from the demo endpoint, so let's use that. We'll store this file in the test resources directory. Let's create a new directory for all the sample files. Let's take a look at this JSON file, and it seems to be correct. We'll just make some changes to the name to clean it up. And we'll copy the path to this file for our code. Going back to the test class, we'll now use this file for the test. So the first verification that we'll make is that the JSON is not null. That's actually the result from the mapping. Now let's go ahead and define this JSON class. We would open up and the sample JSON and split the screen so that we can have both the data, the sample, as well as the class side by side. And we can see that first of all, at the top level, we have meta data. Okay, so let's model that as a class, as an we also have a daily time series that can be modeled as a map of the date and the data. Now let's go ahead and model and create the JSON mapper, the JSON class for the metadata. And finally, we would implement the JSON class for the daily data. Now that the JSON class is implemented, let's get back to the implementation for the alpha vantage get stop price. So we want to get the latest daily closing price from this JSON object that's returned. Um, we'll implement the operations to return the latest daily price from the result we've gotten from alpha vantage. Since this is quite a complicated operation, let's add a logger to look at the result that's returned from the retriever from Alpha Vantage. We also want to add a log in the test function. Now let's go ahead and run the test. And we get a null pointer exception. This is probably due to the fact that we have not set this up as a Spring Boot test. So let's do that for the auto wiring to work. And when we run this test again, it takes a while and it passes. And okay, we can see that the price that's returned is shown, and let's take a look at the data that's returned to make sure that is correct. And we find that we want to log at the info level rather than the debug level to be able to see this this output. And as you can see, we have the result that's from Alpha Vantage. Okay, the last refresh date is in this case is October of and the last closing price is 19.84. And if we look at the result from the operations is 19.84, which means this is probably working correctly. Now that that's working, let's go ahead and refactor this function to simplify it. We remove the log, and then let's try to combine these few operations together. Now let's rerun the test after the refactoring to see whether it still works. And it still passes. So we now go back to the JSON classes to change some of the names to make them more canonical. And we make sure that everything still works by rerunning the test. And it passes. We have now implemented all the different modules and adapters, So as a final test, let's implement a end-to-end test, which means that is it will be an integration test with the MongoDB as well as with the Alpha Vantage adapter. We use the Spring Boot test annotation for this end-to-end test. And to get the web test client, we'll have to use the application context. We'll copy and paste the request from the earlier test so that we know that we are doing exactly the same request. We also copy and paste the verification from the earlier test. In this end-to-end integration testing, we'll have to set up some fake test data to make it work, but there will not be any mocks involved. Everything will be using the actual implementation. We also have to seed the database with this test fixture to make the end-to-end testing work. Now everything seems to be set up. Let's go ahead and run this end-to-end test. And okay, it's not working. Let's see what's happening. Okay, application context is required. Okay, so what's happening now is that since we are auto wiring the application context, and the web test client actually requires this application context before it can be built. We need to move this into the test method so that we can ensure that the context is there when this initialization call is being made. So let's do that. We need to remove the private modifier, and now let's go ahead and run the test again. And we find that it passes. And when we look at the test data, the logs, to make sure that everything is working well. That's the end of the screencast. I hope it was useful, and you can go to the article links and the GitHub repository to get more information. If you like this, don't forget to like and subscribe to this channel. Thank you.